This video is about the distributive principle. So to think about the distributive principle, let's imagine that Colin and Drew are preparing for their Ouija trip. Both brothers need to purchase a $90 sleeping bag for the trip. They also need to purchase a $60 backpack for their gear. So, how much is going to be the total cost of the gear they need for their Ouija trip? Well, Drew needs a $90 sleeping bag and a $60 backpack. So does Colin. So if I add these together, I should get the total cost of their gear. Now another way I can look at this is there's two sleeping bags. So I could say $90 times 2 plus I have 2 backpacks, so $60 times 2. So this is another way of thinking about the problem. Now, let's see if there's another way we can think about the problem. What if we take the $90 sleeping bag and the $60 backpack, add it together because this is what both brothers need to purchase, and take that solution and multiply it by 2. So these are what are called equivalent numerical expressions. They should result in the same solution. So an equivalent numerical expression is when you have two expressions that have the same value. So let's test this out. So if I take 90 times 2, I'll get $180. And if I add that to 60 times 2, I get $120. And my total cost is $300. On this side, I'm going to add 90 to 60, and I'm going to get $150. Remember, I need to do what's inside the grouping symbol first. I'm going to multiply that by 2, and I also get $300. Notice that the solution to both expressions is $300. That's what makes them equivalent numerical expressions. And the distributive problem, our principle, is all about the equivalence of those two. So let's think about this algebraically. This principle is called the distributive principle of multiplication across addition, or for short, the DPMA. For all real numbers x, and all real numbers y, and all real numbers z, this is true. If I have x plus y and I multiply it by z, this should be equivalent to x times z plus y times z. Notice that it comes from the right. Now there's a partner principle to the DPMA, which we call the LDPMA, which is the left distributive principle of multiplication across addition. Again, we're going to have multiplication across an addition problem. So let's look at it from another way. If I have x times y plus z, that should be equal to x times y plus x times z. Notice here we have multiplication. X is being multiplied by both y and z. It also is over here. Notice that I have addition here and here because y and z are being added to each other. These are equivalent. So this is the distributive principle. Now let's think about this in the form of equivalent variable expressions. We know what an equivalent numerical expression was when we did the problem with Drew and Colin going to Widgie. Numerical means numbers, so this was all numbers. Now let's look at it as variables. Let's say I have the expression 9 times 10 minus k. Alright? Notice my 9 is on the left, that's being multiplied. So I'm going to need to use the left distributive principle of multiplication across addition for this one. But notice it's not multiplication across addition, it's multiplication across subtraction. So let's start by finding this as an addition problem. So we're going to what we call DPS it, or use the definition principle of subtraction. So we're going to add the opposite of k. Now let's see if we can find an equivalent variable expression. I'm going to start by taking my 9 and I'm going to distribute it across the addition sign. So an equivalent variable expression to 9 times 10 plus k would be 9 times 10 plus 9 times negative, or the opposite of k. So now I can have 90 plus the opposite of 9k. Notice this is further simplified than I can do here. I can also write this expression as 90 minus 9k, so I can turn it back into a subtraction problem. And you'll find that your book often does this. I like to leave it as an addition problem. Let's try another one of these. Let's say I have y plus 12 times negative 3. I have addition and I have multiplication. My multiplication is on the right side, so I'm going to call this the distributive principle of multiplication across addition. Because my 3 is being multiplied, I'm going to distribute it across my addition sign. And an equivalent variable expression to this expression would be y times negative 3 plus 12 times negative 3. Or a simpler way of writing this would be negative 3y plus negative 36. And that would be my simplified solution to that variable expression. Remember, these two are equivalent variable expressions. Let's do one more problem. Negative 8 times 4z plus 6. Now this one's different because we have a variable with a number. So this is like its own little multiplication problem. So how would we do this problem? Well, again, we have addition and multiplication, so we're going to distribute our negative 8 across the addition sign. Negative 8 times 4z plus negative 8 times 6. What is this called? The left distributive principle of multiplication across addition. This part right here can be confusing, but if you think about it this way, you have negative 8 times 4 times z. Right? Right now these two were grouped, but the associative principle tells me that I can group it here instead. So negative 8 times 4 is negative 32. It's still times z, plus negative 8 times 6 is negative 48. So here, I use the associative principle for multiplication to do this part. And this is the end of the video on the distributive principle.